Hello and welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME question. And in this in this recording, we are going to be looking at the questions for chemistry for the year 2019. This is the second and the concluding part of this recording. We are going to be looking at the last 20 questions that are structured for this year. Before we continue, don't forget to subscribe to our channel, like and share our content. You can also visit our website at scholarlab.com to practice the JAMB exam and modular quizzes for free. Okay, before we begin, it is worth mentioning that in this recording we will be providing straight up or detailed answer depending on the question. So while some questions will require analysis, others are just more like filling the blanks. Okay, time is also one thing that you don't have in abundance in this UTM exam, and so you've got to learn how to save it, and you have to be time conscious. Okay, so we will be saving a lot of time. Also, calculators, yes, they are great and fast, but punching it takes off some time, and so in this recording we will greatly reduce the use of calculators only to when it is necessary. So by learning some tips and some techniques, you can calculate or do calculations, do sums without the use of the calculator. Also, we've provided extra notes on the question and all the solutions, so you can read those notes up as well. Finally, you would also learn to interpret and analyze questions correctly, which is the first step to picking the correct answer. Okay, so let us get started. Alright, first question here. When ammonia and hydrogen ion bond together to form ammonium ion, the bond formed is called a coordinate bond. The bond between the ammonia and hydrogen ion in the ammonium ion is called a coordinate bond. Next question, which of the following represents the kind of bonding in ammonium chloride? The bonding in ammonium chloride is ionic, okay, and dative. We have an ionic bond and a dative bond. The ionic bond is also known as the electrovalence bond. Is a bond that is formed when electrons are transferred from one atom to another atom. Now, in the ammonium chloride, the ionic bond exists between the ammonium ion and the chlorine atom. Okay, between the ammonium ion, that's the NH4 plus, and the chlorine atom. Okay, while a dative bond exists between the ammonia and the hydrogen atom in that ammonium ion. So in this ammonium ion, this is what we have in the previous question. If you remember, in the previous question we have dative bond or coordinate covalent bond between ammonia and hydrogen atom in ammonium ion, which is this, while we have ionic bond between the ammonium ion and the chloride and the chlorine atom. Okay, so it is possible in a compound they are going to have multiple bonds, okay, more than just one bond, as is the case here. So here we have covalent bond between the nitrogen and hydrogen in the ammonia, we have dative bond in the ammonium ion, and we have ionic bond, okay, existing between the ammonium ion and the chloride and the chlorine. Next question, consider this reaction here. What will be the effect of a decrease in pressure on the reaction? So pressure affects reaction involving gaseous species, that is a reaction in which the reactant and the product, or some of them, are gases. So in this reaction here, what you have in this bracket here indicates the state of the substances I have here. So A is a solid, B is a gas, C is an aqueous, that's a liquid, okay, an aqueous solution, while D here is a gas. Now increasing or decreasing the pressure in this reaction is going to it will increase the rate of the forward reaction. Okay, it will increase the rate of forward reaction. An increase in pressure is going to favor the site that has the lower number of moles of the gaseous species, while a decrease in it is going to favor the site that has the higher number of moles. And if you look at what we have here, okay, if you look at what we have here, the number of moles of B here is 2, the number of moles of D here is 1. So this has a greater number of moles. So a decrease in pressure is going to favor the reaction in this to this side. So the backward reaction, the rate of backward reaction is going to, for the general equation of the nature, okay, an equilibrium reaction represented as this. The expression for the equilibrium constant is that would be, we start with the product first. Okay, the product. So here we are going to have, for the equilibrium constant, is going to be equal to R, okay, raised to power this M, the number of moles, okay, R raised to power M times S in brackets raised to power N, that's on the product side, divided by what we have on the reactant side here, P in brackets raised to power X plus Q in brackets raised to power Y. So this is going to be the expression for the equilibrium constant. Remember, the product first divided by what you have on the reactant side, and it's going to be that substance, okay, raised to power its number of mole. Which of the following reactions is an oxidation process? That would be this reaction here. Okay, this reaction here. So what has happened there is the oxidation number of oxygen has increased from -2 to 0. Here, if we calculate the oxidation number of oxygen here, it is going to be equal to 2. Okay, I mean -2. Okay, that will be the oxidation number of oxygen here. Why the oxidation number of this diatomic molecule of oxygen? Okay, the oxidation number of oxygen in this diatomic molecule is 0. So what we have here is an increase in the oxidation number, and an increase in oxidation number is oxidation. Okay, a decrease in oxidation number is reduction. If acidified potassium dichromate 6 acts as oxidizing agent, color changes from, the color will change from orange to green. It will change from orange to green. Next, on thermochemistry, the heat of formation of ethene, that's C2H4, is 50 kilojoules per mole, and that of ethane, C2H6, is -82 kilojoules per mole. Calculate the heat evolved in the process. So we are given the equation of reaction here. Here, ethene reacts with hydrogen to form ethane. Alright, so the heat evolved is going to be equal to the heat of the product. Okay, the heat evolved is going to be the heat of the product minus the heat of the reactants. Okay, the heat of the product minus the heat of the reactants. And here, the heat of the ethane here, the heat of formation of this ethane here, okay, is -82 kilojoules. So you have -82 kilojoules minus, in brackets, the heat of formation of the ethene, okay, that's C2H4, is 50 kilojoules. 50 kilojoules. We take this as 0. Okay, we take this to be 0. So we have -82 minus, in brackets, 50 plus 0, that's 50. -82 minus 50 will be -132 kilojoules. Next, on chemical equilibria, which of the following statements about catalyst is false? Alright, that is the second statement here, that catalysts do not appear in the balance equation. They do appear in the balance equation. However, they do not appear on the reactants or the product side, because catalysts do not partake in the chemical reaction. Okay, they do not partake like reactants in a chemical reaction. So you are not going to see them on the reactant side or the product side, but you will see them on the arrow. Okay, the arrow separating the products separating the reactant side from the product side. So they are usually written on the arrow. But if you look at the other statement, they are correct. Biological catalysts in the body, they are called enzymes. Okay, they act on biomolecules. Catalysts, yes, they reduce the activation energy of a reaction, they lower the activation energy of a reaction, allowing it to proceed, okay, with less energy than normal, okay, than it will require normally. Also, catalysts do not alter the mechanism of reaction, and they do not appear in the weight law. They do not appear in the weight law. We have our website at scholar.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry, and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next, on mixtures, which of the following does not support the fact that air is a mixture? The constituents of air are in a fixed proportion by mass. That is wrong. This is not true of a mixture, because air is a mixture. Okay, air is a mixture, and mixtures are generally impure substances. Generally, they are impure substances. One of the characteristics of impure substances is that they do not have a definite proportion or a fixed. Next question on substances. What technique is suitable for separating a binary solution of potassium chloride and potassium triiosochlorate? That will be by fractional crystallization. Okay, fractional crystallization can be used to separate a solution of potassium chloride and potassium triiosochlorate 5. Okay, we use this method when you have a mixture of two solutes. Okay, a mixture of two solutes, and those two solutes, they have varying solubility. That is, they have different solubility at different temperature. Okay, so that applies to these two substances there, potassium chloride and potassium triiosochlorate. They have variation in their solubility, and as such we can separate them by fractional crystallization of the solids. Alright, on solubility, we have at 27 degrees Celsius 58.5 grams of sodium chloride is present in 250 cm cube of a solution. The solubility of sodium chloride at this temperature is. Alright, we are going to start by finding the actual molar mass of sodium chloride, and that will be the sum of the atomic masses of sodium and chlorine, which is the atomic mass of sodium is 23, that of chlorine is 35, so you have 35.5. Excuse me. So you have 23 plus 35.5, and that is 58.5. Now the given mass of the salt, that sodium chloride here, is 58.5. The number of moles of the sodium will then be the given mass over the molar mass. The given mass here is 58.5 divided by the molar mass, which you calculated to also be 58.5. So you have 58.5 divided by 58.5, and that is equal to 1. Okay. Next, we look at the volume, okay, of the solvent in which that sodium chloride is dissolved, and here that is from the question, it is given as 250 cm cube. We will convert this to dm cube by dividing by 1000, and that will give us 0.25 dm cube. Okay, the solubility in mole per dm cube will then be equal to the number of moles times the volume in dm cube. We already have it in dm cube. Okay, times the volume in dm cube. So this will be equal to 1 times the volume in dm cube, which is 0.25. So this is equal to 0.25 moles per dm cube. Next, on the periodic table, which of the following properties increases from left to right along the period but decreases down the group in the periodic table? That would be ionization energy and electron affinity. Now, what do you call ionization energy? It is the energy required to remove a loosely bound electron, okay, a loosely bound electron, a valence electron, from the shell of an atom in its gaseous form. Now, as you go from left to right along the period, that is from one group to another, the ionization energy is going to be increasing, because you now have more electrons added to the outermost shell as you go from one group to another along the period. But when you go down, okay, as you are going down, more shells are being added, and that means that the electrons in the outermost shell, they are farther away from the nucleus. The farther away they are from the nucleus, the less attracted they will be to that atom, and so it will be easy to remove, those electrons in the outermost shell. So ionization energy, it increases from left to right along the period, but it decreases down the group. Okay, electron affinity is the tendency to accept electron. Okay, the tendency to accept electron. Now as you go from right to left, the tendency increases. Okay, the tendency increases until you get to group 7. The group 7 elements, those are the halogens, they have the highest tendency to accept electron. But as you go down the group, there is a greater tendency to donate than to accept. There's a greater tendency to donate than to accept. So we have II and IV here as the correct answer. The molecular shape and bond angle of water are respectively: the shape of water molecule is bent. Okay, it is bent or V shape, while its bond angle is 105 degree.
You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2 or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, you could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below.
The indicator most suitable for this reaction should have a pH equal to. So this is a reaction between sodium carbonate and hydrochloric acid. The indicator that will be used here must have a pH that is equal to 3. Okay, a pH that is equal to 3 within this range here, 3.2 to 4.4. So that will be like the methyl orange. So the methyl orange is going to be like a good indicator for a reaction like this.
Next question on nuclear chemistry. A radioactive nucleus has a half-life of 20 years. Starting with 100,000 particles, how many particles will be left exactly at the end of 40 years? Alright, so let's start with half-life, understanding what is half-life. Half-life is the time that it takes for a radioactive nucleus to decay to half of the original particle that it has. Now if you say this nucleus A has an half-life of 20 years, that means that after 20 years this nucleus is going to decay to half of this number of particles that it had originally. Okay, now originally it had 100 particles, so after 20 years you decay to half of this, and that will be 500 particles. Now the question is, how many particles will be left exactly at the end of 40 years? So that means for this 40 years now we are going to have two half-lives, like two half-lives. Okay, so what will happen here is, after the first half-life, after the first 20 years of this 40 years, after the first 20 years, this will decay to what? Half. So that will be 500, that will be 50,000 particles. Then after another 20 years, to make 40 years, it will decay again to half of 50,000, and that will be 25,000. So what is going to be left of that particle is going to be 25,000.
Which two gases can be used for the demonstration of the fountain experiment? That will be hydrochloric acid and ammonia. Both are used in the fountain experiment. Next question. Which of the following pollutants will lead to the depletion of ozone layer? That is the chlorofluorocarbons. The chlorofluorocarbons, also known as CFCs. Okay, CFCs or fuels. They are substances that are produced from cooling systems. From cooling systems like air conditioners and refrigerator. These substances, when they escape, okay, they attack the ozone layer in the atmosphere, in the upper atmosphere. They attack the ozone layer. They lead to the depletion of the ozone layer. That is the reduction in the expanse of that layer. Okay, how did they do that? Is by reacting with ozone. Ozone is triatomic oxygen. Okay, O3. So what they do is they react with the ozone
with ozone in that layer, okay, and some really undesirable reactions occur, okay, in which they break off an oxygen from that O3, from that triatomic oxygen, that ozone, so that becomes like diatomic oxygen, okay, and that is not, a building block of the layer. So basically chlorofluorocarbons, they lead to the depletion of the ozone layer. Next question on non-metals. Which of the following describes the chemical property of acids? Acids will react with triazocarbonate. Generally, acids react with triazocarbonate to form salts, water, and carbon dioxide. Okay. If you look at this reaction here, an acid reacts with sodium hydroxide, which is a base, to form normal salt and carbon dioxide. This is one. When acid reacts with bases like that, they form salt and water. Okay, they form salt and water. Then again, even if this had been water, okay, we will still not go with this as the correct answer. Why? Because we don't know what acid is reacted with this. Okay, whether the acid is a concentrated acid or it is a dilute acid, that will determine, the concentration of the acid is going to determine whether the salt that will be formed will be normal, or it will be acidic, or it's going to be basic. Okay, and we don't have enough information from here to tell that the salt is normal. Okay, but generally, when an acid reacts with the triazocarbonate like this, salt, water, and carbon dioxide is produced. Next on mixture. Which of the following pairs cannot be represented with a chemical formula? That is air and bronze. Both of them cannot be represented with a chemical formula because they are mixtures. Air is a mixture of gas. Bronze is a mixture of tin and copper. Okay, it is a mixture of tin and copper. It's an alloy. Okay, and alloys, of course, are mixtures. So both of them, they are mixtures. They cannot be represented with. Alright, final question here. The oxidation number of chromium changes from. Alright, apparently here the oxidation number of chromium here is +3. Okay, +3. But you need to calculate the oxidation number of chromium here. Alright, on this side. Now you can see that in all of the options we have +3, +3, +3, +3. That's because it is very evident to tell. It is very evident that the oxidation number here is +3. Alright, that is why the trick is not here, it is here. Okay, it is here. So this is what they want you to really find out. Okay, what is the original oxidation number of this chromium here? So we say, how do we find that? We say, okay, we have two let's say 2 atoms of chromium here. So you have 2 Cr plus, okay, the oxidation number of oxygen is -2, and we have 7 of it here. So this is going to be -2 times 7. This will now be equal to this oxidation number here of this radical here, and that is -2. So you have 2R -2 times 7 is going to be -14, plus times -14 will give us minus. So you have -14 equals -2. To get the value of Cr here, the oxidation of chromium, we bring -14 here to begin with. So this will become 2 Cr equals -2. -14 comes here, it becomes +14. So you have -2 plus 14, and that is 12. To get the value of Cr, we then divide both sides by 2. Alright, so we have Cr to be equal to +6. That is that the oxidation number of chromium here is +6, and here it is +3. So it has changed here from +6 to +3. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Solubility. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.